Lancaster Woodturners Weekly Coffee Hour number 220 for September 19th, 2024. My name's John Kelsey. I'll be your moderator this morning. I have some work to show. I have a movie to show from Belcher and the ongoing discussion of boring and drill. You say drilling, I say boring. And we have a new guy, Stan Pressner, who has his hand up and would like to introduce himself by showing some work this morning, plus two old regulars with their hands up. So we got a full hour. And since I'm holding the phone, I'm going to do the announcements part. Mid-Atlantic is this weekend. If you're anywhere in range of Philadelphia, or rather Lancaster, you owe it to yourself to attend the Mid-Atlantic Woodturner Symposium. The demonstrator list is fantastic. It's easy to do. It's in the convention center downtown, big parking lot adjacent to it. I don't know what it costs if you're to register on site. There's an instant gallery, there's a trade show, and it's a tight hit. It's like Friday night, bring your stuff, instant gallery, meet the demonstrators. Saturday, a full day of demos. Sunday, demos in the morning, and then a very fun lunch. And then you're done. It's not a 4-day commitment or anything like that. So very great event for anybody who can get to it. I will be there for sure. And the guys you are not seeing on screen this morning, Ziegler, for example, they're offloading lathes. Our club is the location host club. Separate organization runs the event. We bring in the lathes. Our own club lathe belongs to the Mid-Atlantic, or came to us from Mid-Atlantic, and then we do the enormous work of lifting giant one-ways into trucks for a 2-day event. Take them to the convention center, take them upstairs, put them in the rooms, connect them up, get them all set up, and then Sunday afternoon, while the luncheon is going on, take them out of there. So it's a very amazing operation. We've been doing it for as long as the Mid-Atlantic has been running, and it's kind of a lot of fun when it goes well, and it usually does go well. So looking forward to seeing you all at the Mid-Atlantic. Now I'm going to do the minor housekeeping of turning off my background so that I can show you the work that I have right in front of me here by switching to this camera, pushing the keyboard out of the way. These are the little boxes I'm making. They'll be at the Mid-Atlantic because I'm going to put some of them in the exhibition. These are magnet boxes. I'm very happy with this pair. This is a matched pair of two different woods, but the same design. They're 2 7/8 across, roughly 3/4 thick, and when you open them up, they have about a 3/8 inch deep well. 3 magnets. They snap shut tight. What I'm working on is the bead details, the exact little detailings of these things. Now that I've got the tech figured out of boring them, I made blanks for a dozen, and I'm halfway through. So these are 3. Here's a triplet of maple boxes. These are bigger. I find this kind of interesting little optical illusion stuff. Let me get my hands in the right place. Why can't I get my... okay. The small one is 2 7/8 across, and the big one is 3 1/4. The small one, it has a 3/8 inch well inside, and the big one has a 1/2 inch well inside. And they're just so much different in size and heft. And that was one of the things I'm finding out. I'm looking for pocket and purse size things. And then I'm investigating magnet placement as well as beads. These I made one with 2 magnets. It's a little floppy and sticky. I don't think it's not as good as I want it to be. I made one, but it does allow me to use the magnets to make a bridge across the center so I can divide it into 2 compartments. So I'm going to do that next. This one has 3 magnets, and it's the kind of shape that I'm kind of finding it's better if I make a belly of a bead here and let the magnets be inside that. And you can see my bad turning. That's a gouge ding or something ding. A deep scar that I couldn't get rid of because you can't sand magnets and you don't really want to break their metallic integrity. This one has 3 magnets. And this one, which is a design I made in a couple of other woods that I kind of like, this is 4 magnets. And I've been doing 3, I'm going to go to 4 now. That allows one bead to have the magnet buried in it, and it offers more scope for dividing the interior. So I'm going to be doing more experimenting with that. So that's me on magnet boxes. Comments or questions? Take the spotlight off me if you would.
Very nice boxes, John.
Thank you very much, George.
Hey, John. I look forward to seeing. Sorry, I can't find you. Hang on a sec. I look forward to seeing the guys face to face that we often see Saturday morning, and I mean Thursday mornings. And I wonder if there would be a place we could meet, like could say, hey, how about this time? Anybody who comes to Thursday morning Zoom, if you want to have a face-to-face encounter, show up here at a given time. I don't know if there's interest in that. So
You could organize that.
I was afraid you'd say that.
Maybe we
Yeah,
could
that's a
have
nice
a
idea.
coffee hour table for lunch on Sunday.
Oh, that would be good. Hey,
That's
that would
good.
be cool. John, do you wanna get the word out?
Yeah, I'm afraid I'm going to delegate that to you, my friend.
I was talking to John Chill. John Chill.
Well, I have 5 sessions where I'm videographing, so I think that's going to be a little difficult for me to contact people, at the show.
Well, the
Like,
fact that we talked about it here is going to be a clue, but I don't know where we'd meet. But how about we just informally say, let's see if we can find a table, if you want, to gather around and have dinner, have lunch.
on Sunday.
How's that? Yeah.
Yeah, that'd be fun.
Can we figure out like a general location? Like
I'm pretty recognizable. How about where I am?
That sounds
that's a
good.
good idea. Okay. Yeah, and you'll have one of your Florida shirts on, so
Oh, you bet
it's
I will.
easy to Hawaiian. You should
Yeah.
be easy to find.
Yeah,
John, are you
Well,
buying?
Oh,
no.
hey, just one other quick comment. I'm a 60-degree gouge guy, and Stuart Batty's there, so I'm taking a bunch of his sessions. He's the 40.
40-40 guy. Yeah,
Yeah,
amazing.
and so I'm opening my mind enough to see what he has to say. I have never met him in person, so it's going to be a good show. I've already selected my stuff. I'm so thrilled. This one's a really exciting one. So
Well, that's why I brought you my little boxes to show. I'm going to take my little boxes for the instant gallery as well. I don't think they'll let people pick them up, but I wouldn't mind if they did, because anyway, we'll see how that goes. Anybody
Hey,
else on
on
either
Stuart
of these
Batty,
topics? Pardon?
on Stuart Batty, I'll tell you, it's worth going and paying the attendance fee just to hear the stories about his dad.
Yeah.
oh, really? Okay.
Plus, Alan Lacer's going to be there, so yeah, an amazing turner. Yeah. Okay, I'm going to move along. We have a new guy here who wanted to introduce himself, so I'm going to do that before we go to show the video that I've got queued up here from Belcher. Stan Pressner, you wanted to show some work and introduce yourself.
Yep. I've been joining you guys on YouTube for since 2021. I started turning at the beginning of 2021, and realized I was developing bad habits, and went to seek out people as soon as everything eased up a little. And I found Carl Ford and Steve Sherman, who have both been fabulous teachers. Sadly, Steve left us in March. But I'm a 40-40 guy. I'm a recovering theater designer. This is the first one. I'm going from less interesting to more interesting on 4 pieces.
Okay.
A friend of mine called and said he had this maple that had come down. I went over and I grabbed a few little bits of it, and I went, oh, that's pretty interesting.
That's a
So
nice.
I grabbed a ton of it.
That's a nice shape you got there.
Thank you. So this one is unoiled because it's going to be my first experiment with Osmo. This is what they look like oiled.
You're going to like Osmo.
Yeah, I think so. But then there were some huge hunks of the trunk. So this is it cut side grain. This is an 18-inch platter.
What are you turning on? What machine are you using?
A Laguna 1836.
And you're in New York somewhere?
I'm in the Hudson Valley. Yeah, I'm part of the Catskill Woodturners.
Oh, okay. I had the idea you were in Manhattan. I was going to say, okay, now where do you keep that in Manhattan?
I am both.
Okay.
I got very lucky and bought a place up here in early 2019, which turned out to be fortuitous. And I'm spending more and more time up here.
All right.
So I am very happy with this platter, and this wood is just glorious, and I have a lot of it. And then finally on Sunday, this was unfortunate. When this was still a log, it decided I screwed up chucking it, honestly, and it hit me in the face and I lost a tooth. But as soon as I got back from the emergency room, I sort of felt the need to finish this bowl.
What was the screw up? What did you do?
I had drilled mortise and I didn't realize that there was an edge that was catching the chuck, so it wasn't fully engaged. And then the second screw up was turning too fast. But I will say thank God for bionic face shields, because if I hadn't been wearing it, I don't even want to think about what would have happened. You know, it was a 40-pound hunk of wood that hit me in the face.
Wow.
I'm usually very good at staying out of the line of fire. It was a confluence of too many user errors.
Where was the chuck? Which side of the blank was the chuck on, and what state was the blank at when that happened?
I had done the outside of it. I turned it around to core it. And then my tenon broke off, so I turned it back around onto my original mortise, which now didn't hold well, to try to make a new tenon.
I see.
And that's when it let go.
Now, I saw in some of that wood was fairly flawed.
Flawed in which way?
The platter, I think I said, wasn't there a bunch of cracks in the platter?
None.
No, okay, no, the one before that.
This is the only platter.
No, the piece before, I'm misremembering that they were wide.
This looks like a crack, but it's not.
Okay.
Just an inclusion.
Very nice.
So
very nice work.
Thank you. So that's generally what I've been doing. And you guys have been an inspiration throughout this time. All of you except for Toby, because I keep trying to replicate what Toby does unsuccessfully.
Toby's magic.
Ask Toby how long he's been doing, and then you'll realize why he's so good. So
right. But you've all been an inspiration. It's been really terrific just learning various things from all of you, and I thank you.
Stan, I want to make one comment. I've never heard of CA fixing a crack as an inclusion. I'm going to use that. I'm just kidding you. I know it's a wood inclusion, but I'm going to start calling my CA fixes, oh, it's an inclusion in the wood.
Yeah, no, there's nothing in there. That is just, and it's smooth as glass there.
Wow, that's great.
So these are, the last thing is, these are all, I really shouldn't have cut them to finish green, but I did. But I obviously have much more of it that's already roughed out as bowls. But I just couldn't resist getting a good look at it.
Yeah, that's what I can't wait. I go right to where it finished in the first time out, first turn, and let it warp. Okay, any more comments for Stan? All right, nice intro.
Thank you.
Belcher, where are you here? Dennis Belcher. You want to try showing the video from your computer? If you show it from YouTube at your end, it isn't going to work, but you can show it from your own computer.
It's directly off of my computer, and Jim had me save it with specifications what are exactly for Zoom. So we'll see if he's right.
All right, go for
it. Thanks, Dennis.
Go for it, Dennis.
If it doesn't work, it's all Jim's fault. Here we go.
Okay.
And we're going to start with a little bit of history, then move on to a little bit of mechanics. You still got a volume issue?
Fine about safely drilling on the lathe. The first bit of history is in 1860. Morse invented the twist drill bit. Revolutionary revolutionized drilling. But there was a problem. It was very difficult and time consuming to change bits or to change sizes of the bits you were using to drill a hole. So he continued to work on it, and in 1864, he patented the Morse taper. Now, what he realized is that if you take a piece of metal, a shank, and inside that shank, you mill a perfect surface at an angle, and then come to the shank, and on the shank, what you do is you mill it so that it is a perfect complement. Okay? And on the shank, as they came together inside there, that marriage of those two surfaces, as they've come together, had a tremendous ability to resist rotational forces. Now you stop and think a minute for what's happening. Is you can take a 50, 60-pound green blank, put it on your lathe, get your drive center up there, and you put it up there, you bring up the tailstock, and you go at it, and that thing's going around 500, 600 RPM. You're cutting at that wood with a 5/8 inch bowl gouge. I mean, there's a tremendous amount of rotational forces that have to be resisted by this. And yet, as long as that marriage is intact, it happens, and it's great, and it's marvelous. But, and it's the but that's important, if you come into this socket and you put a little ding in it, something that holds these two surfaces apart, guess what happened? Now we've had a corrupted marriage. So instead of resisting the forces, the one stays this way and the other one turns. And you end up with your drill bit remaining stuck in the wood, and turning with the wood rather than being held firmly in the tailstock. And so you end up with a bit that looks like this as that goes flying off into the air. I tell you guys, it's scary. We really don't want that to happen. But it happened all because of this little flaw in the mating of those two surfaces. Now that's critical for us. So the first thing we're going to do in this step of looking at the key components of the lathe is to bring up our chucks, and we're going to look at them. And if I look at this one, what I see really quickly is a whole bunch of dings. Now those dings happen because I had a very poor habit of storing my chucks in a drawer, and I open and close the drawer and they run into each other. So I ended up with a bunch of shanks that look like this, which is really dangerous. Now, it's pretty easy to resolve that. Instead of just throwing them in a drawer and bang, 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 just simply take a piece of plywood, drill some holes in it, and store them like that. All of a sudden, that problem goes away. But nevertheless, that shank is really an accident waiting to happen. The second type of thing that you see is that you will see shanks that look like this. Now here what we have is scoring. It goes all the way around the shank, and that's happened because the shank has rotated inside the socket of the quill in the tailstock, and it has made marks on that. And again, you got the same problem, is now we've compromised the marriage. So the question is, if you have that, what do? Well, the first thing you do is realize that that's dangerous. It's guaranteed to cause you a problem. So we're going to see if we can't replace it. And this is rather amazing to me, is that if I take that chuck, open the jaws all the way up, and look down in the center, what I see is a dimple. So I'm going to take a punch, put in that dimple, boom. Just that simply, we can remove that damaged shank. Now, once that removed, the next thing we ask ourselves is, how am I going to replace it? Well, we're going to look at it very carefully. And what I'm going to see, let's get you a little closer here. What I'm going to see on that is I'm going to see a JT33. Well, that JT33 means that this is the JT portion, and that's JT33 accretion. So what I want is, I want a replacement shank that is a MT2 JT33 33, which is what I have here. Find them on the internet, about 10 bucks a piece. This whole thing is about 35, so it makes sense cost-wise to actually just go ahead and replace the shank and replace the whole drill chuck. We simply put it in there, give it a tap, it's firmly seated. I mean, it's just amazing. A little tap will take it out, a little tap will put it back in, and yet in the meantime, it will resist tremendous, tremendous forces. So that's one part of the things that we need to be careful about, and to make sure that we have, okay, with the shanks of our tools examined, let's move on to the next part, which is here. Actually looking at our quill on the headstock and the tailstock. Now what I'm going to do is I'm going to come in, I'm going to take my finger, I'm going to put it inside the socket. And I do this every time. Before I put anything into a socket, I'm going to take my finger, make sure there's no obstructions in there, there's no finishes built up in there, there's no gunk, there's no dust, because even dust in a socket with the forces involved will over a period of time cause damage to it. You quell it and corrupt the marriage and give you a problem. All right, now part of the maintenance of a lathe should be to clean this. So let's just do that real quick. What I have here is what's called a Morse taper cleaner, or more commonly the green thingy. And I'm going to take a paper towel. I'm going to take some naphtha or mineral spirits, something to dissolve any buildup of tree sap and finishes in there. I'm going to put it into the socket, turn it around, and I'm going to do that until that paper towel comes out clean. Now this is a clean socket, but you know, actually I do see a little bit of black in there, so I'm going to turn this over and I'm going to do it a second time. Okay, so at this point I've done two things. Now we're good. I've checked for any damage inside with my finger, and I've cleaned it. Now, if you do find something suspicious in there with your finger, the next thing to do is to look at an article by Leon Olson at the American Woodturner that talks how to ream out your quills if need be. Now, this is there's some danger in here, so be careful. But these are our reamers. They're not really expensive. They're a coarse and a fine, and they're an MT2. So in effect, if you find high spots in there, what you can do is you can put those in there, rotate them by hand, and cut down those high spots so your marriage is back and the surface is made up again. One of the things that helps you make a determination whether you should go to the trouble to ream or not is this what's called machinist bluing. This particularly one is steel blue layout fluid. The way you use that is you take that, coat the shank with the bluing, put it inside, turn it just a bit, and it'll show you a mark any place. The glue will be gone any place that there's a high spot in there. So that gives you some idea. Now again, I want to warn everyone that you can ruin a very expensive piece of machinery by reaming improperly. Please see the article by Leon Olson in American Woodturner before you attempt to do that. But now what we've done is we've checked the goodliness of our headstock. We're going to do the same thing on the tailstock. Okay, now we have to make a decision about what type of drill chuck to use, and they come in all sorts of various sizes. I mean, this is probably the most common size out there. Find it all over the place. This one, but it's a key type of chuck. This one, there's no key. You can just do it by hand, which is advantageous. You got one less little thing to worry about. This is a behemoth. This is 3/4 inch drill chuck. I mean, this thing weighs like 2.5 pounds. I mean, it's really heavy. This is one I had to come across that I really like. It's a 3/8 inch drill chuck. And again, you don't need the chuck. You can just turn it, holds it fine. The interesting thing is, this is a 1/2 inch. This is the most typical one we find out there. This is a 1/2 inch. But really, almost all the bits we use are 3/8. So this one works quite fine. This is my favorite. This is the one that I use, which is no longer available, so I really can't talk about it too much. But what I really liked about it is this part, the shank goes into the tailstock quill like that. So I have the support of the tailstock very close to the cutting edge of my drill bit. And that's a real advantage, because you have to realize it's the old child's game where they all get in the line and they hold hands, and then the first one starts to move around the playground, and the one at the end, he's running so fast he can't keep up. Well, the same thing happens in drilling. Any kind of give in your tailstock or your lathes or in your drill chuck, you take a little bit of thing back here, by the time it gets to the cutting edge, it's a big swing. So the shorter I am between the support of the tailstock and the cutting edge, the truer I will be able to drill. One that's fairly similar that is available, this is by Carter Products.
John, is that on your end?
Hey, John, unmute yourself again.
Well, electric drill bits won't fit into.
I am unmuted. Can you hear me?
Yeah, I was hearing your heavy breathing and I muted you by accident. I thought Dennis was playing the video. Sorry.
Okay, I wasn't heavily breathing, actually. Anyway, here we go.
This particular one is one made by Woodcut. It's actually called a mill drill. And what it is designed to do is, when you make pepper mills, to actually make two cuts at the same time to speed up, make that whole process more efficient. It's a good system. It also has a drill bit holder, because again, a lot of support and shortens the distance between the cutting edge and the support of the tailstock. Now, if I had to take my choice, what would I use? I'd use this one. Why? Because of the distance, the shortest, and it goes directly to the tailstock. This one works, the Carter product one works, the stout bore system, but it's a little longer than I would really like to have. This one is my go-to. Very frequently for shallow holes. It's just quick, easy, and again, it's a short distance, lots of support. This one I would not use. It's just too big. It won't stop moving when I need it to, and I'm too far away from the support of the tailstock. Now, a lot of difference of opinions. No one is totally right or totally wrong, but the important thing is that you think about why are you using the drill chuck that you're using. In my world, what my belief is the critical thing is the distance of support from the cutting edge to the tailstock. Now, I want to take a minute and talk about this one. We see sometimes this type of a twist drill bit out there. It has the benefit that it goes directly into the tailstock. But I was always kind of nervous about using it, and I couldn't figure out why until I looked very, very carefully. And what I found is, let's see if this shows up or not. If I look at the very tip, there's not a point. That's over a 1/4 inch flat on here. So I would suggest to you that this type of configuration, when you go into the wood, would make it want to wander pretty badly. And this is perhaps a dangerous type of bit because of the configuration of the milling right in here. That would be on my least favorite list. Okay, now we've kind of talked about the scroll chucks and some of the choices you have. The next thing I want to talk about is speed. Right up here by my lathe, on a bulletin board, is a chart that has the various sizes of drill bits and whether it's a hardwood or softwood and what the RPM maximum should be. Now, the key thing is that drilling with a Forstner bit really is a slow speed operation. You need to get the RPMs down. Now, this chart is going to suggest that the RPMs ought to be someplace between 400 and 900. On a smaller diameter, it's going to be up to 900. On the larger diameter bits, it's going to be more like 400. It's better to have the RPMs a little low than it is to have them high. If you get them high, you just have friction problems and problems. Now, again, as I mentioned in the first session, if you find that you have a tendency to want to turn up the speed, it's a sign your drill bit is dull. Go back and sharpen your drill bit. If you find that you got to You want to crank harder and harder to crank on that tailstock handle. It's a sign your drill bit is dull. So go back and sharpen your bits as the first thing. So what we've covered so far is how to sharpen your drill bit. We've covered about how to maintain your headstock quill, your tailstock quill, how to examine your shanks, how to replace a shank that's damaged. All these little things make drilling go easily. You mess up on any one of the little things, you can really trip it up. If this has been worthwhile to you, please give me a thumbs up and hang around for the third session.
All right.
If I can throw a comment out there, as I watch this for the 49th time, I realize there's one thing that I should have added. When you're using set screws to hold a drill bit, you have a tendency to move that drill bit just ever so slightly off center. So instead of being able to come in with 2 points, your points are separated from each other. So you have to be careful with the chucks that hold the drill bit in there with set screws. You need that diameter of the drill bit to match up very closely. I mean, really closely with the hole in your chuck portion. Does that make sense to everybody?
It's the same with drill bit extensions when you're trying to use those, which gets your drill bit way out beyond the chuck. But if the hole's already been started, it's stabilized, but the extension has to really be tighter. It isn't going to work.
Yes, yeah. The other thing that I would ask the group, after I recorded that, trying to get it a little shorter, I upped the speed 15%. Did anybody object to that or even notice it?
Well, I think it loused up your audio.
No, that was a different issue that Jim, by the way, I want to give a shout out to Jim. He was really extremely helpful. I not only changed from controllers from a software to hardware controller and changed cameras, I also changed my video editing program, and he made everything so easy. It was unbelievable. Thank you, Jim.
Hey, don't overdo it. I don't want all the guys calling me.
Yeah, but I got to tell you, it was really expensive.
Yeah.
How's that,
Hey,
Jim?
well, Dennis, I just want to comment about that audio. I had to really crank it up on my Zoom to hear it right. And so I was hearing all the noises, people breathing and everything. And I think, Dennis, we've identified your issue.
Yeah.
You were not on mic. We call it on mic. One of your cameras was picking up your audio, and that's why it was low, and that's why it was hollow. I think we resolved that for Dennis, but yeah.
There's another issue in that as well. Dennis sent me that from YouTube last night. I know I cannot play a video from YouTube, and I anticipated he would bugger up playing it from his computer. So I played the video and recorded it to my computer. But since I was sitting at a table with my wife at the time, the technique I used to doing that also gets all the background sound along with it. So I had the volume down. So I recorded the volume at low gain.
Okay.
So that means we're all woodturners, not video people, right?
Yeah, and it means audio is an ongoing problem. Your words synced. If you want to talk about it, the audio was lousy.
Yeah.
To start with, and I made it worse.
Dennis,
video is easy, audio is hard.
Yeah.
Hey,
Exactly.
Dennis, the content was marvelous. I had an opportunity to step through it. I was looking forward to seeing it. I have one comment.
Yes.
You the twist drill with the flat point, no point, but a flat edge. What I do is I drill a little pilot hole that's wider than the width of that flat point. That's a good starter if you gotta use twist drills because of whatever. And that way it centers right to start with, because you can do a little starter one with say a Forstner bit that's just another 16th or an eighth wider than that flat spot. So
Jim, let me ask you a question. When you learned that little trick, did you have a nasty?
no, I didn't. It's just that I have been struggling with trying to get my bits to go centered on vases and hollow forms and stuff. And so that's part of what it's an ongoing conversation, but I'm learning a lot. I happen to have one of those bits and I like it because it's MT2 on the end. And it's that walking problem that's a problem. You just got to get a good pilot hole to get started.
Well, in the third session on this same topic is going to deal with what we really do and why it goes wrong. It's the operator error problem. I mean, you get the mechanics and the machine's all tuned up properly, and then what's left? Well, it's the hands. It's the old problem. It's the loose nut that pushes the bolt. So,
well, I find the worst problem I see in drilling is people take too big a bite. They use too big a bit at once rather than going in stages. They go in too far before clearing the chips. The deeper the hole, the more often you have to clear the chips. I'm not quite sure why that is, but that's how it is. And if you don't clear the chips, then the drill bit jams, and then you're doomed.
yeah, I'd love to have emails from the group about nasties that they've experienced while drilling. We'll see if that can't be addressed in the third video I make on the topic.
Well,
Can I just throw in something here that the greatest thing that you can have is a machinist center drill.
Yeah.
To start the drilling process. It takes a second to slip it in, and that thing is always precise. It's dead on. It never misses.
Wait to the third session. Wait to the third session. Like it gets a little bit more complicated than that. And it's really funny. At the end of the day, it's the operator and what they know, and if they learn good techniques or not. And the amazing thing about wood turning, I've never had a lesson on drilling. In all the stints at Aramont and all the demonstration over all the years, I've never had anybody take us through from A to Z on how to safely drill. So that's what I'm up to, trying to fill that gap.
Hey, Dennis, the other issue is, excuse me, the heat that's built up. And is that bad technique, bad drill bits, bad what? That's where I find my biggest problem. It starts heating up, and on a thin base, it's starting to make it hot.
That's a dull drill bit and a too big a bite. And
it's too big a bite?
Not clearing frequently enough.
The drill bit is dull. You're not clearing the chips often enough, and you're taking pushing it too hard. Slow down, clear the chips more often, and sharpen the drill bit.
Yeah, Jim, the best sequence to have is you go in there and you drill about 5 turns of the hand wheel, and then you back it out 5 turns, and you sit and have a cup of coffee to let it cool off and come back. Now, at the end of the day, you don't care about what the drill hole is like because you got to run to the bathroom because you had too much coffee. So I solved your problem. Sorry, bad humor.
So I've got a comment on the drilling, and it hasn't been addressed. I haven't heard very many people even talk about it, but it's the accuracy of your tailstock. And I use a center drill all the time, and I use a center drill, and I mark my wood. But when you pull the tailstock back and change it to another chuck or another drill bit, and you run it up, a lot of people will lock their tailstock and then run the drill bit into the wood. And what I've found, even on a Vic mark, it's accurate, but I still run the tailstock until the drill bit is touching the center drill hole. So it very lightens up the tailstock with the headstock, and then lock it. And it only takes a couple thousandths of an inch, and you're off center.
One of the other things, Bert, is to make sure that your tailstock and headstock are exactly on the same center line. And again, I'll address that in the third session. That's one of the things you really need to check.
Oh, and you're exactly right. But I've worked with a whole bunch of different lathes and tried to demonstrate on some, and some of them are the accuracy of the tailstock slide, and it only has to be a couple thousandths of an inch. My Vic mark is awesome, and a lot of the one-ways are awesome. They're pretty repeatable, but there's a lot of lathes out there, and it only takes a couple thousandths of an inch of misalignment, and people don't realize that that's what's happening when they're drilling, is they're actually starting a little bit off. And it's just to be aware of it. There's nothing you can do about it. Just be aware of it.
Well, I find if I have some choice in how I lock that tailstock down. I can push it this way and I can pull it this way. And if I pull it this way, I'm on center. If I let it lock down anywhere else, I'm not on center. That's idiosyncratic to my lathe, and I only know that from getting it wrong a lot.
And that's exactly right. So you recognized it, and I'm just mentioning it that let people know that, hey, you know what, you can do that. You can find out what works for your lathe and then keep doing it.
Yes, and then you can go into a round of adjusting on your lathe. On some lathes, a more adjustment range in the, for how the tailstock sits relative to the headstock than others. But it's really a matter of learning your lathe.
I think also it's a matter of how expensive a lathe you own. I cannot afford a $5,000 or $7,000 lathe, but I suspect that we would find their tolerances are a lot tighter and remain that through the life of the lathe. I'm not sure that's true with mine.
I had a shopsmith one time, a $600 machine, and it was dead on. So, you know, go figure.
Okay, all right. Yeah.
Anybody else on this topic, this boring topic?
I did have another question. I want to know about the keyed and keyless chucks. Is there a difference in accuracy? Is there any kind of difference at all other than speed?
It's tighter.
From my experience, I've not detected any differences between the two. No, but the group out here has a lot of experience out there. Let's see what somebody else has to say.
I can get more leverage on a key than I can twisting, so I can get a keyed chuck tighter. That's me.
Anybody else?
I can get mine tight enough by hand with the keyless, and so that's my first choice most of the time.
Me too. Yep. Yep. Anybody else? Anybody else on this topic?
Yeah, one other thing between the two, I think the keyed chucks, as a general rule, I think tend to be a little larger, a little longer. The keyless are. The keyed chucks tend to be a little bit shorter because I guess there's less mechanics in there or something.
Well, I was really surprised when I found that small 3/8 inch drill chuck. What it was, it was two pieces. I mean, I found the piece that you turn that clamps it down, and I suspect it came actually from a hand drill. And then as soon as I saw it, all I knew I had to do was to match up the taper, you know, the MT2 to whatever that number is, the JT, whatever. And as soon as I did that, I had a wonderful short distance drill chuck. I mean, I was really pleased with that. And I don't know if I've seen that size of chuck for sale in the wood turning catalogs.
What manufacturer of keyless chuck have you guys found to be the best?
Don't have an opinion.
Well, there was one that they no longer sell, but if you can find a used one, it was a very good quality. I think Woodcraft sold it. It was called Golden Goose, and that was a keyed chuck.
Yeah,
and
that was
very high quality at a reasonable price. My keyless chuck, somebody did a group buy on chucks that they got from someone that was selling these chucks designed for CNC machines. They were made in China. I think I paid about $35 for it. Very high quality, very nice. I don't know where it came from, but you could tell because they were sold for CNC machines, they just seemed to be a higher quality than the ones you get from Penn State or Harbor Freight or, you know, some no-name knockoff.
I like the robust. I have a robust. I think that's what Dennis is holding up there now is a robust.
This is a ME, it looks like, but it's a Harvest, HARVEST. But I got to tell you, the real problem with this chuck is I could not figure out how to change the tang. I couldn't get the taper out. It doesn't come out. Don't know how. And I ran across another wood turner who had the same chuck, and his was all chewed up. We got to talking, and he went home and tried to take this part out to replace it also, and could not figure out how to get it apart. Where the Golden Goose one that Mike talked about, which is what I demonstrate on, I mean, it's just as easy as anything, just to tap it and it comes right out.
Hold that one up, Dennis. Hold the end of it up, because I think the one thing that a lot of people don't realize, the Golden Goose is also, the back end of it is threaded, so you can put it in your headstock and use a drawbar. That one is more of a problem.
But some of the tangs have that threading, some don't. So if you go a step further, it's a JT33 MT2 threaded. And the next question is it an 1/8 inch rod or a 3/8 or a 5/16 inch thread inside? But we'll talk about that next session.
Hey, Dennis, have you tried turning it backwards to pull the Morse taper out? And I say that because all of the bits that you put in, the chucks that you put into a regular drill bit, a regular drill, you have, the screw is reverse thread. It's a left-handed thread instead of right-handed. And that's done because it tightens when you use it.
But that taper is not thread. That's a taper. It's not threaded.
But it may be threaded into the chuck body.
In here?
Yeah.
I don't think so.
Or either that or
some of them are built that way with threads, and the ones that are threaded in the chuck body are left-hand thread. You're absolutely correct. I've seen that.
That will be a thing to try to get it out.
Yeah, Rick, thank you. I'll give it a whirl.
Yeah.
Sure.
Anybody else on this topic?
They do make, excuse me, wedges that you can use to remove that from a chuck.
I'm familiar, Randy, I'm familiar with the wedge you're talking about because I use it on my drill press when I got to change out a chuck on the drill press. But there is no place here for that wedge that I can see.
Drift pin.
Okay.
Okay. But my drill press, yeah, it's a wedge removable.
I have a right angle drill that, if I'm not mistaken, the chuck has a screw that holds it in there.
Yes. Yeah, you don't find those with the lathes, but yeah, I've come across that also, John.
Yeah. Okay. I assume you've looked in there and there's no screw.
Not that I can see, but I'm going to try what he suggested. I'm going to loosen her back up and then take this tang, put a wrench on it, and see if I can unscrew it. See what happens.
Anybody else on this topic?
What about a double pickle fork?
You got me. Keep talking.
Keep talking, Malcolm. You had your hand up anyhow. What do you want to tell us?
Well, that, excuse me, I'm sitting here not talking for a while. Is there a small shoulder just before the tang goes into the chuck? I can't see that right now. You're not highlighting.
No, there's not. There is a small shoulder right here. But
that's exactly what I'm talking about. What if you put a double pickle fork, one from either side, a wedged fork, like a ball joint puller? That could be.
Good gear.
Let me finish.
Okay.
That could be a straight shank, not a tapered shank. It may be designed not to come out of there, but it may be that you can wedge it out of there if you can't disassemble the chuck and jack it from the other side.
Well, I think the other thing that you really have to deal with, I mean, chucks are, $30 to $50, and you get to a certain point, you say, well, okay, when this gets a little bit more wear on it or it gets banged at all, it's simply a throwaway. It's just not safe, which is really what's important. Because I tell you, I bent one drill bit. I don't want to do it again. So. John, it's to you.
Yeah, it looks like we beat this one to death. Chalikian, you got the floor.
Myself, I'm muted. Okay. I have several things to talk about. One, 2 weeks ago, John mentioned about Constantine. This is a supply house that used to be in the Bronx. This catalog is from 1994-95. I've been hanging on to it because they have a lot of interesting stuff. They've moved to Florida, and they still have the 50 sample pieces of wood to, for a wood identification. They also have a lot of different kinds of finishing products and all sorts of stuff. Very interesting. So they're at Constantine's with an S.com. So they're still around. The that sample box went from like $25 to I think $46. I looked it up. So the company is still around. Real interesting, very interesting products. Well worth checking out. I have a couple of things that I've turned. Just finished this. This is I think northern pine. It's a pine. I believe it's northern pine. And
bring it back. Hold it still. What's going on in the middle there?
Well, decoration. I textured it.
It's textured rather than just okay.
Yeah. Using a just a rotary bit. Forget the exact name. Like a grinding, like for a sanding thing with texture ball. And just a simple little thing. Next piece is this is I believe it's Cedar. It could be you. And very nice real nice grain. Beautiful. The one thing I wanted to start a discussion on about this, I was turning and I was trying to get it smooth, and I made a couple of real nice fine cuts, and I still couldn't get it smooth. And what I realized as I was doing it, that the grain, because it's hard and soft, I could not get it as smooth as I really wanted. I mean, it's relatively smooth, but I wanted to just see how people, if there's any special techniques or any people have experienced, hard grain, soft grain, and how they deal with it. So just kind of open that up for discussion. Any thoughts?
Anybody on that?
If the bottom of your bowl is somewhat flat, I've had success using an oscillating sander that has a 4-inch disc on it, because that will, that will remove that little undulation in the middle. Might work for you.
Okay, thank you.
I do shear scraping, both with a gouge and also a very, very light touch with a negative rake, freshly sharpened negative rake scraper. Just
I did do that. I did do shear scraping, and I did try a negative rake on it. Like I say, I mean, it's relatively smooth, but I can still feel some differences.
One thing you can try is put a finish on it. Let the finish let the finish completely cure, and then go back and cut it, because it'll stiffen the fibers. And you're taking light cuts anyhow. It'll only take the high spot.
Also, it's important to remember that you can feel with your fingers much smaller deviations than you can see. Your fingers are sensitive down to the 10,000ths of an inch. It's amazing what we can detect.
Yeah, John, also be careful as you sand that your backing pad is quite stiff, not the soft one. If you have hard, soft wood and have a soft sanding pad, you'll end up with undulations across that. So you might go back and look hard at your sanding pads, and if they're the soft type, they're going to cause you that problem.
I'd go in with a hard rubber block on that in that case.
Okay, yeah, I tend to use a softer, if I'm just doing it by hand, I have like a piece of foam that I use as a backer. And some of it I have the handheld, 2-inch disc kind of a thing. That's soft too. Okay, that's a good suggestion. Thank you.
Yeah, I think we might solve your problem right there.
I think so too. Yeah.
Yeah, if you do power sanding, sometimes it helps to keep the disc rather flat on the surface than compared to angling it. So if you have the disc rotating at an angle, only the outer portion of the discs is sanding, and that tends to give you more removal of softer parts than of the harder parts. So if you sand, keep the disc rather like this and don't angle it. Does that make sense?
Yeah.
I think it does. It kind of reminds you of what's the best cutting angle on wood, 45 degrees. So if you turn that disc up at an angle, you're going to get more cutting.
Exactly.
Yeah. Yeah. But in general, I agree with John. Very fine shear scraping often does the trick and leaves a nice surface, and then followed by sanding with either a hard disc or a hard block. You put the sandpaper around and sand it by hand. So a minimum of sanding and a maximum of shear scraping, if that is possible.
Also for sanding, especially in situations with a soft wood like that, slow the lathe way down, slower than you think you ought to. Slow it way down, or less rippling. I don't know why that works. And the same with the final cuts. I've been finding that the slower I can make the final cuts, the better surface I'm going to get.
It makes you think a little bit about like using a chatter tool. The faster you turn, the coarser the texture.
Yes, see, it's an analog to that physical phenomena that's going on there. This is a case where slower is better. We not 3,000 RPM is not the way to go. 30 is more like it.
So today we've learned that shorter is better and slower is better. Good things.
Just like us in our old age, I'm shorter.
Oh, geez, yes.
We're coming up on 11 o'clock. If there's anybody who's got absolutely dying to say something, now's your moment. You guys with your hands up who want to show work, I hope to get to you next week. We're always here every Thursday morning. Anybody out there on YouTube, as we have one new guy from YouTube this morning, Mark Tremblay from I think Calgary. Yeah, tell your friends if you've got guys who you think would like coffee hour, get them in touch with me and I'll add them to the email list. They can join us. It's free. How about that? Something that's free in this world. Who knew?
Hi, John. This is Randy.
Hi, Randy. You're at the convention center.
I'm at the Mid-Atlantic Woodturning Symposium. We're setting up for our weekend. And this is what looks like in one of the rooms. And this is our stand.
The lathes haven't arrived yet, though. They're doing the lathes now, I think.
I don't think they're here yet.
Yeah, you'll know when they are.
But they're not here yet.
They arrive with a clatter.
Yeah, and right behind that is our video boom. And over on the table is our switcher box. And so we're getting it all set up, getting ready for the weekend.
Very good. Well, I hope to see you all there. Yeah, let's do have a coffee hour lunch on Sunday. You'll find me. I'm easy to find. It's not a huge conference. That's the beauty of these weekend events. I think they're much better than the national. Couple of hundred people, fabulous demonstrators, short hit, not expensive. What could be better than that? See you all at the Mid-Atlantic and see you all next week.
Wood shop. Thank God for wood.